If we look at section 3.5, we really just have two items that are in this section, very related to section 3.4. First of all, we have the 5-number summary. So the 5-number summary is the 3 quartiles along with the smallest data value and the largest data value. So the minimum, the maximum, and then the 3 quartiles. So I've asked you to use the smart car data from the previous section to determine the 5-number summary. Well, we found the quartiles last time, and we're talking about the original data. So I manipulated the data a little bit, but we're talking about the original data, the 24 data values. The median, or the second quartile, was 38.35, the first quartile was 36.85, and the third quartile was 41. So those are 3 of the 5 numbers in the 5-number summary, and I'm going to write them in order. So 36.85, 38.35, and 41. Those were the 3 quartiles. So if I will put with those the smallest data value, which was 31.5, and the largest data value, which is 47.5, then that gives me the 5-number summary. So the smallest data value, 31.5, and the largest data value, 47.5. So those 5 numbers give us the 5-number summary. Well, so what? What's the 5-number summary? What's it do for us? Well, the 5-number summary gives us an idea of both the center and the dispersion of the data. So if you'll keep in mind, like the 38.35, that is the median, that's the middle value. And then I can kind of see how the data is dispersed around that center. For example, if I find the difference between 38.35 and 36.85, so I'm going to just take and subtract that. That's a difference of 1.5. So the only difference there is 1.5. As it compared to, what if I compare 41 with 38.35? 41 minus 38.35, that's a difference of 2.65. So 2.65. Now those aren't any of my numbers in my 5-number summary, but here's my point. 25% of the data values are between 36.85 and 38.35. That's not spread out very much. That's very consistent. 25% of the data values are between 38.35 and 41. That's not spread out that much, 2.65. That's the range of that. Now that 1/4 of the data is more spread out than this 1/4 of the data though. So they're both pretty consistent, but this 1/4 is less consistent than this 1/4. In the same way, if I find the differences here, 36.85 minus 31.5, that's a difference of 5.35. So this 1/4 of the data is much more spread out than these 2/4 of the data. And in the same way, if I take 47.5 minus 41, that's a difference of 6.5. This 1/4 of the data is more spread out than the other 1/4s of the data. So again, it's giving me this idea of the dispersion as well as the center. So that's the significance of the 5-number summary. Now, box plots are graphs that represent the 5-number summary. So box plots, a graph based on the 5-number summary, sometimes called a box and whisker plot. So a box plot is just a visual representation of the 5-number summary. A box plot's going to look something like this. We have a box, and then we have 2 lines sticking out of that box called whiskers, which is why it's sometimes called a box and whiskers plot, okay? Now what's happening in this box and whisker plot is this vertical line right there in the middle of my box is representing the median. This left side of the box represents the first quartile. The right side of the box represents the third quartile. So this is the median, this is the first quartile, this is the third quartile. So the box itself is showing me the area from the first quartile to the third quartile. So that's really representing the interquartile range. And then the whisker extends over to the largest data value, and this whisker extends over to the smallest data value. And so again, that's giving us a visual representation of this 5-number summary. Now, typically, if our data includes any outliers, we will also want to flag those outliers in the box plot. We don't have to, but generally we will want to identify outliers with our box plot. So how do we go about drawing a box plot? Well, the first step really is to identify any outliers. So we're going to determine the lower fence and the upper fence to identify any outliers. Draw a number line long enough to include the maximum and minimum values. Insert vertical lines at Q1, M, and Q3. So again, I'm going to draw a number line so that I have a scale, and I'm going to draw vertical lines at the median and at the 2 quartiles, the first quartile and the third quartile. Label the lower and upper fences just so we can determine outliers. Draw the line from Q1 to the smallest data value that is larger than the lower fence, and then draw a line from Q3 to the largest data value that is smaller than the upper fence. These are called the whiskers. And then if we have any outliers, we're going to denote those by some other mark, such as an asterisk. It doesn't have to be an asterisk, but that's what we'll typically use. So, using the smart car data from the previous section, construct a box plot. Now, in the previous section, we identified the lower fence to be 30.625. We identified the upper fence to be 47.225, and that meant that the data value 47.5 was an outlier. So we've already done the work that we need to construct a box plot. So all I'm going to do to construct this box plot is I'm going to start with a number line, and I drew a number line that started at 30, and I started at 30 because our smallest data value was 31.5, and I went to 48 because our largest data value was 47.5. So I just have this number line with those values labeled. So I'm going to start by finding the quartiles. Now again, the first quartile was 36.85. So 36.85 would be around in here on my number line. So I'm going to draw a vertical line above that on the number line. The second quartile was 38.35. So that would be around here on my number line. So I'm going to draw a vertical line above that. My third quartile was 41. That's around here. And so I'm going to draw a vertical line above that. And so I'm going to connect that like this. And so that's called the box of my box and whisker plot. Now my fences, again, we had found to be 30.625. So 30.625 would be around in here. And 47.225 would be around in here. So I'm just kind of marking those so that I know what they are. Now, we also had found that 47.5 was an outlier. So that's the only data value that was outside of the fences. So again, what we do next is we draw our whiskers. So I'm going to draw a whisker from the first quartile down to the smallest data value that is not an outlier. Well, 31.5 is the smallest data value and it's not an outlier. So I'm going to find it and I'm going to extend a whisker to that value. So 31.5 would be about here. And so my whisker is going to extend to that. 47.5, my largest data value, is an outlier. So I'm not going to extend my whisker to the 47.5. Instead, I'm going to extend it to the largest value that's not an outlier, which for the smart car data is 43.5. So 43.5 would be around here. So I'm going to extend my whisker to about there.
And then for the 47.5, the outlier, I'm going to label that with an asterisk. So this would be my box and whisker plot, or my box plot for the smart car data.
Your calculators and StatCrunch can also construct box plots. So let me show you that real quick. So I have my data, this is the smart car data in list 1. So I have all 24 data values in list 1. So if I want to create a box plot, I'm going to, let me pull my calculator back here. I'm going to go to stat plot, which is the second of the y equals. So I hit second and y equals. I'm going to choose a plot and turn it on. Now we actually have two different box plot options that we could use. The first one here, you see it looks like a box plot, and it's got two little dots there. The two little dots indicates that the calculator will identify outliers there. The other box plot, the calculator will not identify outliers. So you can either identify outliers or not identify outliers, depending on which one of these you choose. Now, I don't ever see a reason not to identify the outliers, so I'm generally going to use this first one. So I'm just going to select that. I tell the calculator where my data are, and I had my data in list 1. So I'm ready to graph this box plot. The only other thing I need to do is choose an appropriate window. Well, in terms of the window, I can do basically what I did here. My X-min needs to be smaller than or equal to the smallest data value. Well, our smallest data value was 31.5, so either use that for X-min or a convenient number like 30 just below it. Likewise, the X-max needs to be either the largest data value or a convenient number a little bit bigger, so like 48 or 50. The scale doesn't really matter that much. It's just going to be how often you see a tick mark. So you could use a scale of 1 if you wanted to, or a scale of 2 if you wanted to. It's up to you. The Y-min and the Y-max doesn't really matter at all in this graph. The only thing that affects is whether or not you're going to be able to see the horizontal scale. So I like to make my Y-min 0 and my Y-max like 10 or something like that. A scale of 1 would be fine. And if I hit graph, there's my box plot. So again, making that 0, making my Y-min 0 puts the x-axis at the bottom of my screen. If I were to change that and make my Y-min like -10 and the Y-max +10, then that just puts that number line in the middle of the screen. It doesn't change the graph, it just changes the position of my number line. If you hit the trace button, the calculator will show you what the 5 numbers in the 5-number summary are. So like, for example, it tells me that the median is 38.35. And if I move to the left, it tells me the first quartile is 36.85. And it tells me that the smallest data value is 31.5. Now, if I go to the right, it tells me that the third quartile is 41. And then if I move to the right again, it tells me that value, 43.5, that is the largest value that's not an outlier. And then if I move one more time, it tells me that the largest value is an outlier because it's flagged with that symbol, and it is 47.5. So what the calculator does not tell you, it doesn't tell you what the fences are. Obviously, the calculator finds the fences in order to identify that 47.5 is an outlier, but it doesn't display what those values of the fences are. So I tell you that so that you know if you have to actually know what the fences are, like in a homework problem, you're going to have to calculate those by hand. The calculator's not going to tell you what they are, and incidentally, neither is StatCrunch. Let me show you StatCrunch as well. And I have the smart car data already in StatCrunch. If I want to create a box plot in StatCrunch, I'm going to go to Graph, and then I'm going to select Box Plot. When I do, I get this window. So this window is like a lot of the other windows we've seen when we do statistical calculations and when we create graphs. So the first thing I got to do is tell StatCrunch where the data are. So in this case, it's in this column that I've called Smart Car. That's about all I have to do. I do want to point out that there's this option right here that's got a selection by default that says use fences to identify outliers. So you have the option of not identifying outliers if you remove that check mark, or identifying outliers. Again, I don't really understand a reason why we would not want to identify outliers, so we're going to generally leave that check marked. Now look what happens when I say compute. StatCrunch gives me this box plot. StatCrunch by default draws the box plots vertically rather than horizontally. So our number line's over here vertically, and it's drawing that vertically. There's nothing wrong with drawing box plots vertically, but we're generally going to draw them horizontally. Before I show you that, if I point at the box plot, I want you to notice the display that shows up. So there were 24 data values, and one of those was an outlier. The interquartile range, it tells me, is 4.15. The upper limit, what the upper limit is, that is the largest data value that is not an outlier. So that's not the fence. That's the largest value that's not an outlier. So that's 43.5. The third quartile, the median, the first quartile, and the lower limit is the smallest data value that is not an outlier. So that's what this tells me. If you want to know what the outliers are, you have to go point at them. So if I point up there, that's the outlier, 47.5. Now again, personally, I prefer my box plots horizontal instead of vertical, but that's my personal preference. StatCrunch does give you an option right here with the fences to draw the boxes horizontally. So if you will also put a check mark in that box and recompute, then I get my box plot horizontally instead of vertically. So again, if I point at that, it will tell me all of the 5 numbers in the 5-number summary, unless you have an outlier, and then the outlier is there. So back to my notes. I do want to point out that we can identify the shapes of distributions by using box plots. If you take a look at this first graph that I have here in the notes, if we had a set of data, and if we made a histogram, and if the histogram looks like this, clearly that's a skewed right distribution. Well, the box plot would look like this. So I'm using the same data, in other words, right? It's skewed right data. Here's what the histogram looks like for that data. Here's what the box plot looks like. So do you see how the box plot shows the skewed right distribution? Clearly, the left side of this distribution is less spread out than the right side. So the long whisker, the long box, is indicating that we have a skewed right distribution. In the same way, if we have a set of data that has this histogram so that it's bell-shaped, then the box plot's going to look like this so that it's bell-shaped. You see how perfectly symmetric that looks? So that's indicating we have a bell-shaped distribution from the box plot. And similarly, if we have a set of data that's skewed left, so then we see that we're much more spread out on the left side of the box plot. So that indicates a skewed left distribution. So you may be asked to draw the box plot, and then from the box plot, determine if the distribution skewed left, skewed right, or bell-shaped or symmetric. I've given you instructions here. We demonstrated it, but how you can create a box plot using the calculator, how you can use StatCrunch to create a box plot. And then I have one last example. One benefit of a box plot is that we can sometimes use a box plot to compare 2 different sets of data. So really what we're doing is we're going to use side-by-side box plots. And if we use side-by-side box plots, we can compare the distributions of data. So take a look at this problem here. Chips per cookie. Do store brand chocolate chip cookies have fewer chips per cookie than Keebler's Chip Deluxe chocolate chip cookies? Now, this is an important topic, right? We're comparing store brand cookies to Keebler Deluxe chocolate chip cookies. And the question is, do store brand cookies have fewer chips in them than Keebler Deluxe chocolate chip cookies? So a topic close to my heart. To find out, a student randomly selected 21 cookies of each brand and counted the number of chips in the cookies. The results are shown in, well, I say in the next column, but I cut this out of the book and put the data below. So we have 21 Keebler Deluxe chocolate chip cookies, and we have 21 store brand chocolate chip cookies. So one of the Keebler cookies had 32 chocolate chips in it. Another had 28. Another had 25, and so on. One of the store brand cookies had 21 chocolate chips in it. Another had 24. Another had 26, and so on. So we want to draw side-by-side box plots for each brand of cookie. And I'm going to use technology to do this. So I entered the Keebler data into list 2 of my calculator, and I entered the store brand data into list 3 of my calculator. And I'm going to create side-by-side box plots for the Keebler and the store brand data. To do that, I'm going to go to StatPlot. I'm going to choose a plot, and I'm going to turn it on, which I've already done. So we did this with the smart car data. So I'm choosing plot 1, and I've chosen box plot. I just need to tell the calculator that my data is in list 2. Now in list 2, that's the Keebler data. I also need to create a box plot for the store brand data. So I'm going to go to StatPlot again, and this time I'm going to choose a different plot. I'm going to choose plot 2, and I'm going to turn it on, and I'm going to choose box plot, and that is going to be for the store brand cookies, which I have in list 3. Now notice on my color calculator, my store brand box plot's going to be red, whereas my Keebler box plot's going to be blue. So all I really need to do now is choose a viewing window. Now I haven't found the 5-number summary, so I don't really know what window to choose. So I want to show you a shortcut. It's called Zoom Stat. And Zoom Stat will choose a window that will fit the data that you're trying to graph within the window. So if I choose Zoom Stat, the calculator is going to pick a window for me. And so if I trace, like right now I'm tracing the Keebler data. So the smallest value was 20, the first quartile was 21.5, the second quartile is 25, the third quartile is 28, and the largest value was 33. There weren't any outliers in the Keebler data. If I move down, the largest value in the store brand data was 33, the third quartile is 27.5, the median or second quartile is 24, the first quartile is 21, and the smallest value is 16. Again, there weren't any outliers in either set of data. Now, the calculator chose a window from 14.3 to 34.7, which is fine. It left my Y's, what I had before. I'm going to change that to be 0, just so the number line's lower and it's not over the top of my box plots. So this is a side-by-side box plot. And the significance of it is it allows us to compare the distributions of the Keebler cookies with the store brand cookies. So, question B, does there appear to be a difference in the number of chips per cookie? If you think about like in terms of like the average, now the box plot doesn't really show me the average, right? But it shows me the center. The center here is 25. The center here is 24. Well, there's not a big difference there. They both have about the same median. And likewise, if you look at the quartiles, 27.5 versus 28 and 21.5 versus 21, there's not a huge amount of difference there. If you look at the largest number of chips, 35 or 33 rather, and 33, those are the same. The only thing that's different is that Keebler's minimum number of chips was 20, whereas the store brand was down to 16. So there was a little bit of difference on the low end, but otherwise there wasn't really a whole lot of difference. So does there appear to be a difference in the number of chips per cookie? My answer here is a little bit debatable. We could debate on a perfect answer for this. There probably isn't a perfect answer. So what I would say here is probably not really. There's really not a significant difference in terms of like the center, but maybe a little bit on the low end, but maybe a little on the lower end. So again, we had a minimum of 16 here and 20 there. So a difference of 4, that's a little more significant than the differences in the other place. But the real point is these overlap a bunch, right? They overlap a whole bunch, which is kind of indicating that they're really actually kind of similar distributions. Again, the store brand may be a little more skewed left. So that is the store brand has a lower minimum. The rest isn't all that different. I said skewed left, but it's really not even skewed. Does one brand have a more consistent number of chips per cookie? Well, I would probably say that's probably true. So the Keebler seems to be a little more consistent in the 20 to 30 range, whereas there's a little more dispersion in the store brand cookies. So does one brand have a more consistent number of chips? Again, we could debate this answer, but I'm going to say yes, Keebler is more consistent. So that's kind of the idea. Just really quickly, let me come back to StatCrunch. So I have the Keebler and the store brand data here. If I want to create a side-by-side box plot in StatCrunch, here's how I do it. I go to Graph. I go to Box Plot. I'm going to select both columns, Keebler and store brand. I want them to be horizontal, so I'm going to put that check mark there, and I'm going to say compute. And when I do that, I have the store brand box plot on top here and the Keebler on bottom here, which looks a lot like my calculator one, except the calculator had this one on the bottom and this one on the top, but that doesn't really matter. And again, I can point at them to see what the 5-number summaries are for each of them, and so that I can answer my questions. Again, the main point is there's a lot of overlap here. So the store brand probably has just got a little more inconsistency in the number of chips you're going to have in the cookie, but on average, it probably has the same number of chips as the Chip Ahoy.